Hi, so welcome, and we're going to be looking today at some binomial distributions and using hypothesis testing on those distributions. The first example here, Dritty grows tomatoes. So over a period of time, she has established that the probability of a tomato being over 4 centimeters is 0.3. We got a new fertilizer, we want to test its efficiency. We imagine if the fertilizer works, then the probability that a tomato is over 4 centimeters will have increased. So I'm going to start by defining my statistic, and I'm going to say that X is the number of tomatoes over 4 centimeters. Okay, and then why can we use a binomial for this? Well, there are 4 factors that you need to think about for a binomial. Firstly, you need to have only 2 outcomes. So our 2 outcomes here are over 4 centimeters or not, so that's fine. We need a fixed probability. We're told that it's 0.3. That's fine, we've met that. We need to know that each trial is independent, and we can assume that from the data we're given. And finally, there needs to be a fixed number of trials, and we're shown in the question there are 40 in the sample. So we can use a binomial, and the model is going to be X can be mapped as a binomial with 40 trials and a probability of 3. This allows us to set up our hypotheses. H0 is that the probability is equal to 0.3. The alternate hypothesis is that it's greater than 0.3. So we can see that this is a one-tail test at 5% significance. Okay, we can write out the rest. That's all gained from the question there. I've stated my hypotheses clearly, and I have done this here. That means that what I'm looking for is the probability that I get the test statistic, in this case 18 tomatoes, has to be smaller than 5%. Okay, so let's go ahead. Right, we're told that we get 18 tomatoes. What's the probability that X is greater than or equal to 18? Well, we can't find greater than or equal to 18 on the calculator or from the tables, but we can find 17 or less. And if we do 1 minus that, we'll get the probability that X is over 18. So from tables or from your calculator, you get the value is 0.9680. So that's 0.0420. Now, that calculation is very important, and despite having drawn through my answer, I promise it is important. What we can do now is compare that to the significance that we were interested in. 0.420 is less than 0.0420. 0.0420 is less than 0.05. Therefore, there is evidence to reject H0. And as that is the case, we have to state our conclusions clearly. So it's very important. There's evidence to reject H0. That's the first step. We can accept H1. There is evidence that the fertilizer is more effective. And that's what we need to do for this question, fertilizer. Okay, that's the first question done. I hope that made sense. Okay, good.